In this video, we shall explore the properties of the range. There are some good properties and one seriously bad property. Let's start with the good ones. Range is easy to compute, easy to understand. Good points. Now, here are a couple of more good things about range that show that it captures the intuitive idea of dispersion. Suppose I take some points and all the points are squeezed down to a single point. Now there is no dispersion among them, right? So, here is desirable property number 1. If all the values are equal, then a measure of dispersion should be 0. Is this true about range? Well, if all the values are the same, then that same number is both the minimum and the maximum, and hence their difference is also 0. Now here is another desirable property for a dispersion measure to have. We again start with our set of values. Now if all the values are just by shifted by the same amount, then do you think the dispersion has changed? Intuitively, it should not change, right? Because they have just moved, not come closer together or move further apart. So here is desirable property number 2. Dispersion should remain unchanged by a constant shift. Is it true about the range? Yes. Because when you shift all the numbers by some common amount, the minimum and maximum also get shifted by the same amount, so their difference remains the same. Well, next comes yet another desirable property. We again start with the values along a number line. They have some dispersion. Now suppose we multiply all the numbers by some constant, say c. For instance, if I take c equal to 2, then we just double all the numbers. Then the dispersion also increases. It should change according to that constant c. If c is greater than 1, like in this case, then the dispersion should increase. If c is between 0 and 1, then the points are squeezed together and hence dispersion should go down. The sign of c should not matter. The sign merely controls if the points are flipped around 0. In short, a good dispersion measure should get multiplied with absolute value of c if all the numbers are multiplied with c. Does range satisfy this property? Let's see. In this video, we are going to show that if I multiply all my numbers, this is my data set, by some fixed constant, suppose I multiply everything with 2, then the range also gets multiplied by 2. Well, what is the range here? The range is, this is the minimum and this is the maximum. So here range is 16 minus 2, that is 14. Now if I multiply all the numbers by 2, then what happens is that this number changes to 6, this to 18, this to 4, and this is 32. Since 2 is a positive number, so the order is preserved. So here this was the minimum, now this is the minimum. Here this was the maximum, now this is the maximum. Both of them have been multiplied by 2. So if I look at the difference between them, the new range is 32 minus 4. So that is 28, which is double this quantity. If on the other hand, I had multiplied it by minus 2, then all the numbers would have been their negatives. Now the order is flipped. This is no more the minimum. This is the maximum and this is the minimum. So when now I want to compute the range, what I will do is I will be taking 4 first So I will be subtracting minus 32 from minus 4. So I will be doing minus 4 minus minus 32. But observe that this minus 4 is this minus 4 and two minuses will give you a plus. So this will again be same as 28. So whether I multiply the numbers with a positive quantity or a negative quantity, in both cases I end up multiplying the range by only 2. So the sign does not play any role. Now that was one example. We can turn this into a general proof like this. For the general proof, we start with our data x1 to xn and we take any number c. And we multiply all these numbers by c to get our new data set cx1 to cxn. Now suppose we look at the value where it takes the maximum value. Let x subscript max be the maximum. For example, if x5 is the maximum, max equal to 5, x max. Similarly, x min be the minimum value. Then range is equal to x max minus x min. Now if c is positive, then c times x max is the new maximum and c times x min is the new minimum. Therefore, the new range is just this minus this, so c times r. If on the other hand c is negative, then this is the new minimum and this is the new maximum. So the new range is minus c times r. But minus c is precisely absolute value of c. So in either case, the new range is absolute value of c times r.